Okay, this is Chapter 3, Section 3. We're still talking about graphing equations, and we just have this reminder. We're going to concentrate mainly on linear equations, although you were actually shown in our last section, Section 3.2, how to graph equations that aren't linear. But now we're going to turn our focus to linear equations, and this is really important. So a linear equation in two variables can always be written in the form ax plus by is equal to c, where both a and b are not 0. That means a could be 0 or b could be 0, but not both. Now if a were 0, the x value wouldn't even appear in the equation. You'd have like 7y is equal to 20. If b were equal to 0, then the y term won't be in the equation. You'd have like 10x is equal to minus 2. So the point is, if you ever wonder whether an equation is linear, then you can actually try to write it in this form, ax plus by is equal to c, where both a and b are not 0. And they say that this form is called the standard form. There's some debate about whether such a standard form exists, but that's good enough for us. And when the b term, in other words, when a y term actually appears in the equation, so when b is not equal to 0, which means y appears in the equation, the general form of the equation can be solved for y. And when we solve for y, let's actually do that. Some of you could always use some more practice on how to solve for variables. So we have ax plus by is equal to c, and your task is to solve for y. So again, what we're going to do is we want to get the y term all by itself. And the way to do that is we subtract the ax term from both sides. And when I subtract it from the left-hand side, it vanishes. And now what do? Well, we have that b times y, remember a, b, and c are real numbers. So I know how many b times y is. We know b is not equal to 0 by supposition. So to find out the value of y, I just divide both sides by b. And you have to divide every term over here by b. So that gives us y is equal to minus ax plus c all over b. Now this is a perfectly good form, but we kind of want to do a little bit of algebraic manipulation. What that means is we're going to transform this to a identical equation, but looks slightly different. And we're going to use, and we use this commonly, constantly. This is the rule that we use for adding and subtracting fractions. If we have a plus b over some number c, then that's equal to a over c plus b over c. So this is really the rule of adding two fractions. A divided by c and b divided by c are two fractions. And how is it that we can add them? Well, we have to have a common denominator. They both have to have the same denominator, c. And once we add them, all we do is we just write a division line over the common denominator c, and then just add the numerators. So I'm going to do the reverse process of this up here. This gives me y is equal to minus ax over b plus c over b. Now I'm going to rewrite this even some more. I'm going to say let m is equal to minus a divided by b, and I'm going to write small b instead of large b is equal to c divided by b. And when I do it, I have y is equal to mx plus b. And this is a very important form of a linear equation. This is called the slope Y-intercept Now here I'm going to tell you, all of this math down to here, you don't have to memorize that. It's good that you should be able to derive that on your own. Indeed, my own view is if this were to appear on a final exam question, everyone should be able to do it. And if you're not able to do it, you really probably shouldn't be passing the class, because what comes next, college algebra, is going to require that type of sophistication and more. But for right now in 3.3 you don't have to derive it. But I did want to show you that that derivation gets us to this. So I solved for y, then I renamed introduced two new variables, m and b, and set them equal to minus a over b and c over b, and I get y is equal to mx plus b. So let's go back. So y is equal to mx plus b. This form of a linear equation is called the slope-intercept form. And we're going to talk about the concept of its slope in just a bit. So here we're literally going to convert the following linear equations in general form to the slope-intercept form. So let's go ahead and do that. So remember, we're given an equation. This is 1a, 5x minus 4y is equal to 20. So notice this is a linear equation in the variable x and y, so that means it's going to have an associated graph. And what we want, this is what we want over here. Over here, I want to convert it. This is what we're given. This is the given over here. And this is our goal. Our goal is to convert it into the form y is equal to mx plus b. Now you can literally memorize the formula I just gave you, but it's going to be so much easier not to do that and just solve. So that's our goal. We're finished when we identify the m and we identify the b, because those are what we have to find out. So let's go ahead and do it. Again, like all things, you have a lot of options here. And I want to show you one more thing, because the left hand and the right hand side of an equation can be switched. This equation right here, y is equal to mx plus b, is the same as mx plus b is equal to y. And we do not care where, if the y is on the left hand side or on the right hand side like it is down here. Now I'm going to go ahead and make the y on the left hand side, but you don't have to do that. As a matter of fact, the reason I mention that is it's probably going to be a little bit easier to do it this way, but it shouldn't matter, and indeed this is what we're going to go for. I just want to show you, I just wanted to mention mx plus b is equal to y, and y is equal to mx plus b. They are the same. They are the same. So let's go ahead and let's isolate my y term. And how do I do that? I subtract 5x from both sides. Now in this case, I'm going to put the minus 5x here, and then I'm just going to scoot the 20 over and put a plus sign in front of it, because that's what it is. It doesn't have a minus, it doesn't have anything, so the assumption is it's a plus. So again, I just moved the 5x over to the other side, and it became negative, and I just happened to write it in between the equals and the 20. I just scooted the 20 over to the last. Why? Because my goal is to get a mx term. And yet, one more thing, I mean literally, another thing, y is equal to b plus mx, is all of these are equivalent forms. But the suggestion was to write it in the form y is equal to mx plus b in that order, even though mathematically it does not matter. That's what we're going to do. So here, I need to divide both sides by minus 4. Here's the easiest way to do that. Just divide each term by minus 4. So minus 4 divided by minus 4 gives me a y, so that's going good. So minus 5 divided by minus 4, we prefer it without the negatives, is 5/4 times x. And 20 divided by minus 4 is equal to minus 5. And I'm done. Y is equal to mx plus b. My m value is 5/4, or 5/4, and my small b value is minus 5. So that was an awful lot of detail for one problem, and I'm not going to go into that detail again. I'm just going to go ahead and work through this next problem, and I suggest that you pause the video right now and try to do it yourself. So again, I'm going to move the 12 to the other side. I'm going to scoot it right there next to the equal sign. Of course, the 12x has to change sign, and the 6 still appears, but it has to be scooted over. So then I'm going to divide both sides through by minus 3. And then it's just a simplification process. Minus 3 divided by minus 3 is 1. So that leaves me 1y. Minus 12 divided by minus 3 is 4. And that's multiplied by x. And 6 divided by 3 is 2. So again, we have y is equal to mx plus b, where m is equal to 4 and b is equal to, minus 2. Notice what I did there? I forgot. I just divided 6 by 3 instead of minus 3, but I caught it. The point is that you catch your mistakes. And really, the best way to do it is, I make mistakes like this all the time because I'm talking and writing and thinking ahead. But when you're actually doing it, you've got to focus all on your math. And when you get done, it's a good idea just to glance up here and see that everything is okay. And at that point, if you actually did that, you would notice, oh wait, that term right there, I forgot to write the minus 3. But I caught it, and that's all that matters. Let's go to the next objective. So is the following an equation of a line? This is a really good challenge question. So we have x is equal to 5. Is this a linear equation? Well, by definition, we know it's a linear equation if it can be written in the form ax plus by is equal to c. Now, earlier I introduced to you the slope-intercept form of an equation, but I did not say that every linear equation could be written in that form. As a matter of fact, let's bump up here. So we can only get to the slope-intercept form when the value of b is not 0. But the general linear equation, ax plus by plus c, covers all bases. Every single equation whose graph is a straight line, every linear equation, is of that form. Now, if b happens to not be 0, then all of those can be converted to the slope-intercept form. But notice I'm not asking down here, and we're not attacking this problem by trying to put it in the slope-intercept form. I go back to the general equation. So I'm given x is equal to 5. So that means a is 1, but there is no y term. What am I going to do? Well, if I let b be equal to 0, then 0 times any value of y is 0. So if you wanted to, you could just say 1x plus 0 is equal to 5, which gives me x plus 0 times y is equal to 5. I guess I could put the 1 there. So I have it in the form ax plus by is equal to c. And we do not have both a and b equal to 0. And that was the only restriction on the very first general form. So yes, indeed, this is the graph of a straight line. It will be, this is going to be an important form. So I'm just going to tell you right now, the graph of this line is a vertical line. Straight up and down. Straight up and down. So if this were my coordinate axis with my origin right here, this is my y-axis, this is my x-axis, this point right here would be 5 and 0. And that's supposed to be straight up and down. It's not perfect, but I just wanted to show you this would be the graph of x is equal to y, because every point on it, 5y, has as its first x value, remember these are values x, y, x equals to 5. And here I ask another question. Can you convert x equal to 5 into an equation of a line in slope-intercept form? And the answer is no, because our b value, go back and bring it back up, our b, our a is equal to 1, our b is equal to 0, and our c is equal to 5. And in order to begin to convert it into slope-intercept form, we cannot have b equals to 0. Why is that? Because we literally divide by, in its original derivation, we divide by b, and we can't divide by 0. So just an awful lot of stuff. I'm literally taking my time on this one because I want you to get the concepts down, and really it's the concepts that that play an important role. And I just sent out a PDF of a list of concepts and definitions that are really important for this chapter. So it says convert the following linear equations in general form to equations in slope-intercept form and determine the slope in the y-intercepts. Okay, do I intercept? Yeah. So here we have a new concept. So let's actually go over to Geogebra. So here I'm going to put a point right here. Now here is a line, right? This line right here, I'm going to leave the mouse alone. This line is going through point A. But this is a different line. I slightly moved the mouse and I drew a different line. That means, as we discovered earlier, that for a given fixed line, I need 2 points. But another way to observe that is if I know something called the slope, and if I have the slope and a point, then that's also going to determine a line. And what is the slope? You can think of the slope as the steepness of a line. So right here, this line is more or less horizontal, and it doesn't have any slope. If this represented a tabletop and I put a marble on it, it wouldn't roll off. Now if I slowly give it a slope, the marble would roll off, and roll off at a faster and faster speed because the slope is increasing. Actually, when it's pointing this direction up, then the slope is positive. Now we're finally going to get to a horizontal line, and the ball can't even stay on the table, right? That's because the slope is undefined. I said horizontal line, I meant to say vertical line. I've got a vertical line right now, and the marble wouldn't even stay on it. So vertical lines don't have a defined slope. Now as I can continue to go this way, I've got a negative slope that's really, really large. It's getting smaller and smaller and smaller and smaller, the negative value of the slope, until I reach the horizontal position again, and it's 0. And now as I continue to go down, it gets a slope again, which is positive and increasing, positive, increasing, larger, larger, huge, huge. As we get close to a vertical line, the slope is huge numbers, almost unimaginable numbers. So unimaginable, we might say the slope is infinity. We don't say the slope is infinity. We say the slope is undefined. So it reaches a point where there is no slope. Then I move on, and then we have really, really large negative slope, getting closer to 0, closer to 0, closer, decreasing, 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 until I get to 0 again. So that's the concept of a slope. So for a linear equation, so let's do a little drawing here. So this is going to be my line. Well, let's just do it the right way, okay? Maybe I can do it this way. New painting layer. Copy layer to clipboard. Did I get anything? No, I didn't get anything. I actually have something copied to the clipboard. We don't need to do that. I had something copied to the clipboard. That something is no longer there. Let me go ahead and freehand draw. And I've done something here. There we go. If I zoom in an awful lot, things get blurry. Things get bigger, but of course their pixelation gets more blurry. Just like if you try to digitally zoom in. So this is going to be my coordinate axis, coordinate plane, that's my X, and that's going to be my Y. So this is the X-axis and this is the Y-axis. And now I'm going to draw, in this case I'm going to I'm just going to draw through the origin, in this case a line. So this line right here, let me draw it in another color. So this line right here that I drew is, again, it goes on forever and ever. It extends this way too. So what is the slope? Well, let's pick a point on this line. And let's pick another point on that line, and this one is going to be through the origin. And what I'm going to do is I'm going to measure two things. Again, I want a different color here. I'm going to measure two things. I want to measure the height and we call the rise, instead of the height, I'm going to call it the rise, and the run between those 2 points. So remember, here was one point, which was the origin that I chose. You don't have to do it. And here. And the ratio, if I take the rise and I divide it by the run, that actually turns out to be the slope. And the cool thing, if you've had any geometry at all, suppose instead of putting this second point at the origin, I were to draw another point right here. So we're going to draw so this is going to be rise and a run. So maybe rise 1 and rise 2. So by this I mean the rise is this right here. So as it turns out that because these triangles are similar, that the rise 1 over the run 1 is exactly the same ratio as this rise over this rise. So it doesn't matter who I pick my 2 points, the ratio between the rise and the run is always going to be the same, and that's going to be the slope. So when we have an equation in the form y is equal to mx plus b, the value m is the slope. So the slope, you see, is much better seen as a ratio of rise over run. So if I have y is equal to 5x minus 3, then m is equal to 5. But that's equal to 5 divided by 1. That means its rise is 5 and its run is 1. So what is the b value? Now, let's look at Geogebra again. So notice here is a line. I'm just going to put another point down there. And this line, this is the y-axis here, and this is the x-axis. This line crosses the y-axis right there. Let's draw us another line. This line also crosses the y-axis right there. Let's draw us another line. Well, I'm getting ready to go all out, so that's good enough. That line crosses the y-axis right there. So are there any lines that never cross the y-axis? Well, the only lines that generally do not cross the y-axis are vertical lines. But there is one vertical line that crosses the y-axis. If you'll recall, the y-axis is a line itself. So that's the only line that crosses the y-axis. It's the only vertical line that crosses the y-axis. And it's the y-axis, which it self-intersects at every point. So here, an awful lot of lines have been drawn. The point is, we have, let me cancel this, we have places where each one of these lines that have a defined slope, and they're not vertical lines that are equivalent to the y-axis, they cross the line at the point. So at each one of these points where it crosses the y-axis, the x value is 0. So that's what I'm trying to illustrate graphically by this. The y-intercept is not a value, it's a point. The point where the line crosses the y-axis. So over here, that point is right here, and its coordinates are always 0 in the x slot, and in this case 0, 0. So this point is the y-intercept. So why do they call y is equal to mx plus b the slope y-intercept form? Because there are no points in it. Because the value of b gives you the y value. So let me stop right here. The value of b is really all you need to know to produce that point. So the general form for a point that crosses any point, the y-axis is, I know half of the coordinate of the ordered pair is 0, I'm not going to put y there, 0b. So we know automatically the value of the x. But remember, every ordered pair is of the form x, y. So x is equal to 0 and y is given to be equal to b, and that's it. So back up to over here. If I have y is equal to 5x minus 3, then m is equal to 5, and if you want to write that as 5 over 1, and that's the slope. And here's the thing you have to be careful. Some of you will have done this in high school, and they always teach this wrong in high school unless you go to a really good high school with someone who really knows their math. The y-intercept is not equal to minus 3. And I don't know how many high school students come in and say, oh, y-intercept is equal to minus 3. That's lazy thinking. The y-intercept is a point. So the y-intercept can easily be gleaned from this value. It's 0 minus 3. So the y-intercept always has a 0 in the x slot. And all you have to know is the value of the b. And when we have y is equal to mx plus b, that b value here is what is inserted here. So the point is, the y-intercept is not a number. The y-intercept is a point. And if you have an equation in the form y is equal to mx plus b, you already know that the point, the x value is going to be 0. All you need to do is find the value of b, and this gives you that value. And the slope is a real number. So let's summarize that. Slope is a real number. In other words, y is equal to mx plus b. Slope is m, not m times x. The x is not part of it. It's this real number m. And b is the second coordinate. Of the y-intercept, which is given by 0b, and the y-intercept is a point. Remember, points are ordered pairs, but the y-intercept is an ordered pair whose x value is always 0. All you have to do is find the y value where it crosses. So all of that big spiel, I never get to go into that kind of detail in the classroom, although I always feel that detail is necessary because we just don't have time. But you have time now. Those who get it can fast forward. Those who need it have to slow down. So we're going to convert the following linear equations in general form to equations in y-intercept form and determine their slope and y-intercept. So we're ready to literally do this now. And I'm going to do 4a. And I'm going to, since I spent so much time on all of that, I'm just going to do 4a, and then I'm going to tell you the answer for b, and I'll let you work that out on your own. And remember also too, I don't harp on this a lot, when I typed up these notes, I literally looked at the examples given in our book. So each one of these examples should correspond to a worked example in the book that you can always open up your ebook and go to 3.3 and find 12x plus 7 is equal to 7 and see the worked out solution. So minus 3x plus 4y is equal to minus 20. So remember, our goal is to get it in the form y is equal to mx plus b. That's our goal. So what I'm going to do is I'm going to start and leave my 4y there, and I'm going to move my minus 3 term over. It changes its sign, and notice that's a minus 20. I'm just going to scoot her over. And now what I do is I'm going to divide each term by 4. So that gives me y is equal to 3/4 times x minus 20 divided by 4 is 5. So my slope m, remember, that's a real number. The x term's not included, is 3/4. And that corresponds to the ratio of the rise over the run. And my b value is minus 5, so the y-intercept, do not write down y minus 5, because that's incorrect. Y-intercept is an ordered pair whose first value is always 0. This gives me my b value, minus 5. Okay, and for the second one, b, 12x plus 7y is equal to 7. So the slope is going to be, I'll write down the answer, you all can work it out, and it will give you some confidence. 12x plus 7y is equal to 7. M, or the slope, is going to be equal to minus 12/7, and the b value is going to be equal to 1. Yes, 1. So that's the b value. So the slope, y-intercept, is going to be 0, 1. This is the y-intercept. And the b value, clearly, remember the y-intercept is always 0b, and when b is a y value, and this is equivalent to y is equal to minus 12/7 x plus 1. Okay, so let's go on. So let's graph linear functions. But I'm going to introduce you to a new concept. Let's go back over to Geogebra and get rid of a lot of these. Delete, delete, delete. Probably just easier to turn them off, right? Man, I got a lot of them up here. And I've got one. So yeah, there's a line. Let me just draw that line. I can get rid of those points too. I'm going to go back to a point. I'm going to turn it off. So here is a line, and notice that line has a y-intercept down here. And the y-intercept is the point where the line crosses the y-axis. So this is my y-axis. But the line is also crossing the x-intercept here. So this is called the x-intercept. So visually, the x-intercept is the place where the line crosses the x-axis. So notice at any crossing point on the x-axis, the y value is 0. So every y-intercept, every x-intercept is an ordered pair of the form some number c, comma 0. So let's go back over to here. The point where a line crosses the x-axis is called the x-intercept. You've seen that visually now. To find the x-intercept, set the value of y to 0, because every point on the x-axis has a value of y equals to 0, and solve for x. The y-intercept can be found by setting x equal to 0. So that's really important. Thus the point 0b is the y-intercept, and the point on the graph given by C0 is the x-intercept. And let me tie this into something else I just sent you in an announcement. So when we're graphing, so suppose we're given a linear equation, and I'm not going to write one down. You can just imagine that we're given a linear equation. If you want, you can imagine that linear equation is given in general form, like minus 7x plus 3y is equal to 100. And you're asked to graph it. And I suggested that the graphing requires that you do a table of values. The table of values have an x column and a y column. And you get to choose. You can choose an x value. And then once you've chosen an x value, you plug it into the original equation and solve for y. Or if you wanted, you could choose a y value, plug that value in, and then solve for x. For linear equations, the kitty corner, the double choice, one of your choices is you choose x to be equal to 0, and you solve for y. Y is equal to what number? When x is equal to 0. And your second choice should always be y is equal to 0, and then you solve for x. X is equal to what? When y is equal to 0. So you're going to have a point 0 and some number b, and then down here you're going to have a point where y is 0 and x is equal to some number c. So b is some actual number and c is some actual number, and this turns out to be the y-intercept, and this turns out to be the x-intercept. So you have two intercepts, and on the graph sometimes it doesn't work out. I don't like this color anymore. Sometimes it doesn't work out exactly as nice as you would like, because they're points that are really, really close. But the y-intercept, if you think about it, is going to be some point that intercepts the y-axis. This is y again, and this is x. And the x-intercept is going to be some point that lies on the x-axis. So once you have those 2 points, in particular when they're really a long ways away, you can draw your line. Now, of course, this is just a line segment, as I don't have the best tools. You would want to go ahead and, to your best knowledge, you can use a ruler, whatever, but that would be what the line would look like. So let's go on. So the cool thing about it is we can find the x and the y-intercepts of the following equations. So the first example, we have to remember. They've already thrown something at you. This is common in math. What is this f of x stuff? Well, if you recall, f of x is equal to y, always. So what this means is, what they've actually told you here, and this is literally a function, it's a linear function, but you can rewrite it as y is equal to 3/4 x minus 2/5. So this is in the form y is equal to mx plus b. So you already know the y-intercept. The y-intercept is always a point where the x value is 0, and all you need is the b value, and the b value is minus 2/5. Oh man, that was super simple. But we are going to have to do some work to find the x-intercept. The x-intercept is some number c, but our y value is always equal to 0. So what we do in this equation is we're going to make things a lot simpler. I don't want you all using fractions. So I'm going to transform this into an equivalent equation that will be easier to work with. And the first step I have to do is I have to find the LCD of 4 and 5. Well, 4 and 5 don't share any common factors. So the LCD is just their product, which is 4 times 5, which is equal to 20. So I'm literally going to multiply both sides of this equation by 20. Well, one side, that's going to be easy. And here you have to be really, really careful. You have to multiply the entirety of the right-hand side by 20. So that's going to give me 20y is equal to 20 divided by 4 is 5. So 5 times 3x is 15x. 20 divided by 5 is 4, and 4 times minus 2 is minus 8. Wow, isn't that much nicer? Wouldn't you much rather work with an equation like this? So now what do? We set the value of y equals to 0. So equal to 0. So 20 times 0 is 0 is equal to 15x minus 8. And we solve for x. Solving for x here is really simple. I'm just going to move the minus 8 to the other side, and it becomes 8 is equal to 15x. Now I want to know how much 1x is, so I divide both sides through by 15, and x is equal to 8/15. So the point up here is going to be 0, and 8/15. I'm getting something different here. Did I write this down wrong? Hold on. My answer that I've written out here is not corresponding with my notes, so let me make sure that I wrote down the problem as stated, and let's check it again. Oh, no, 3/4 x minus 2/5. So it could very well easily be that my answer given here is the fraction reduced. 20 divided by 5 is 4. That's right. 4 times minus 2 is minus 8. 20 divided by 4 is 5. And 5 times 3x is 15x. And 20 times... So I'm declaring this is the right solution. I just had to divide through by... So what I've done, I'm sorry people, what I have written down on my page over here is fine. This is exactly what I have. What I did not do for my notes on that page is find the x-intercept. And this is indeed, there was no error made. I was just looking at my notes. In my notes I actually don't work out this problem. This part of the problem right here, not this. So the x-intercept, and I thought that meant I'd done it, had an error, but I did not. Intercept is going to be equal to, we found out the value of c. The value of c is 8/15. That doesn't reduce 0. So this is the y-intercept here. This is the X-intercept. Okay, so let's do one more of those. So I'm literally seeing in my notes, I gypped my students from half of the question because they really literally want both X and Y, and in my notes that I have written out, I only found the Y-intercept and they wanted both. So let's go ahead and do one more of these now that I know that's what's going on in my notes. So again, we have B. We want the X and Y-intercept. 2x plus 2y is equal to 1. So you have two paths to go here. You can convert this, you can solve for y, and when you solve for y you'll have mx plus b, and then you will have the value for b that works for our y-intercept. But we're going to do it a different way. And then what you have to do is by doing so, the work pays off that you find the y-intercept easy. But you still have to find the x-intercept, and the x-intercept requires that you set y equals to 0. So let's just do it another way. It's a way to illustrate the table of values. So let's pretend like we were going to plot it. And many times, the easiest way to plot it is to find the X and Y intercept. So we do kitty corner zeros. And this first one is going to be the Y-intercept. Why? Because X is equal to 0. And the second one is going to be the X-intercept. Why? Because Y is equal to 0. It's good to have an image here, because notice when X is equal to 0 you get the Y-intercept. When Y is equal to 0 you get the X-intercept. So here's what we're going to do. Here's my original equation. So what I'm going to do is I'm going to come over here and I'm going to so this is my given. I'm given X is equal to 0. I'm going to find the value of Y. So I plug in 0 for X. So that's 0 plus 2Y is equal to 1, because 2 times 0 is 0. So that gives me 2Y is equal to 1. So now I'll solve for Y. So Y is equal to, I divide both sides by 2, is equal to 1/2. So this gives me the point 0, 1/2. I wrote it right here. I guess I should have written it over here. 0, 1/2. Now we're given that Y is equal to 0. Find X. So I go to my original equation. 2x plus, I plug in 0 for Y, is equal to 1. So that gives me 2x is equal to 1. I divide both sides by 2. I get X is equal to 1/2. So my X-intercept is 1/2, 0. Now unfortunately, if you're given a graph, like the graphs I give you right here, you have to eyeball where the 1/2 is. So these points would be really, really close. I mean, that's not the best in the world, but it's something, right? So here's the deal. All you care about is your grade, right? So if you were asked to find the X and Y intercept and plot it, and you chose this method, and you clearly state that your X-intercept is this, and your Y-intercept is this, and you're trying to find where those values are, as long as you're in the ballpark for the graphing part, I'll say that's okay too. Okay. So let me give you two more pieces of information. Or maybe three. The graph of a vertical line, that's a line that goes straight up and down, is given by x is equal to b. So b is a constant. where B is the X-intercept. So B, the point B comma 0, is the point on the x-axis where the vertical line intercepts. The graph of a horizontal line is given by y is equal to c, where c is the y-intercept. So the point 0c is the point where the horizontal line crosses the y-axis. The slope of a vertical line is undefined, straight up and down undefined. However, the slope of a horizontal line is 0. So straight up and down, the marble can't even stay on the table, undefined. A horizontal line, the marble is on the table and just sits there and doesn't roll. That's because there's no slope, 0 slope. So here we want to graph the following equation. X is equal to 5 and y is equal to minus 2.75. So let me see if I can make this magic work. Copy it to the clipboard, come over here, actually start a new canvas, go to layer, and paste layer from the clip. Wow, it did work. Not so bad. So here we go. So x is equal to 5 halves. So when I say x is equal to 5 halves, then I already know that I have a vertical line. So here is kind of good to know where is 5 halves. Well, you should know that this is equivalent to x is equal to 2.5. That means every point on the line we have a value of x equals to 2.5, and we have that the x-intercept is 2.5 and 0. And the only reason I'm doing this to 2.5 rather than 5 halves is when we want to locate things on a graph, it's sometimes helpful to have the number line in a decimal form. So here's my number line. That's 0, that's 1, that's 2, that's 3, that's 4, that's 5. So I'm going to say 2.5 is about right there. And this is still x is equal to 2.5. You just kind of go straight up and down. All you really need is 2 points, and then you just draw a line through those points. And if you do it right, it should be a vertical line. So this is the line, or the graph of the equation, x is equal to 5 halves. But that wasn't everything we were asked to do. We were asked to now do y is equal to minus 2.75. Well, I know this is a horizontal line by what I just told you, horizontal. So its y-intercept is 0 minus 2.75. And every point on the line has y, the y coordinate, equal to that. So let's see what we can do here. So I've got to find minus 2.75 on the y-axis. So that's minus 1. This is minus 1. This is minus 2. And this is minus 3 right here. So I'm going to eyeball it and say 2.75 is right, minus 2.75 is right there. And I'm going to draw me another point saying that's about minus 2.75. I know really it looks more like minus 2.5, but that's the problem with this, right? You just kind of got to eyeball it, and we're going to draw our line through there. It's going to be a horizontal line. To the best of your abilities. No, you're not allowed to use GeoGebra for this. And this is the line y is equal to minus 2.75. Okay, let's get a new canvas. And go back. Seriously, is that it for this lecture? Okay, that's it for lecture 3.3. I went into quite a bit of detail, but hopefully the detail helped.